to show you some of the things that happened, why that happened, and the incredible challenge to try to prevent something like this from being as devastating in the future. 15 inches of rain drop in a short period of time, some places are going to flood. And the question is, what can be done to help remedy part of it? And this flood control effort has been going on. Many, hundreds of millions of dollars spent by Harris County in conjunction with the U.S. Corps of Engineers. We depend on Congress to help us with floods. We depend on their money. The interesting thing when it comes to flooding and trying to prevent floods is sometimes people don't want to see what we need to do to land to make it hold water. In areas where we've had to chop down hundreds of trees and make detention areas. You got to have some place for the water to go. People over here don't want to see Cypress Creek look like Braves Bayou, concreted. So there's challenges as we try to do flood control work without, some people say, ravaging the woods and the forest and whatever. So it's a challenge. Environmentally, it's a challenge. And there are some people, frankly, over the years, and the years I've been doing this, that frankly enjoy floods. They like to see a flood about every 7 years because they want new cars. They want their homes redone. And that went on. And then Harris County Flood Control, in conjunction with the federal government, came in and started buying out people. And that was a very stressful situation for a lot of people. They didn't want to give up their home that frequently flooded. We took it. You'll see some areas out here where there used to be a subdivision that all of the homes are gone. So buyouts are not popular in most situations, although some people want us to buy them out. So what I'm going to do, Mike, are you going to come up here now?
I can.
Mr. Talbot, he's been the head of Harris County Flood Control for, what, 2 decades? Huh?
Yeah.
Close.
18 years.
18, that's close enough. So at any rate, I'm going to give you Mike, and we'll get back with you.
Mike, one quick question.
Thank you, Commissioner. This is being live streamed tonight on the internet. Go to cypresscoalition.com. So it's live streaming in case you're on the computer later on. Thank you.
All right. Yeah, I've been director of the Flood Control District for 18 years, been with it for 35, so I've been through a lot of the changes over the years with that. What I have tonight is, actually there's 2 presentations. Each one of them takes about 45 minutes, but I'm going to do it in 30. So we're going to skip a rock across the surface of some of these things, but I'll be running through all the slides in the show just so you can understand this. This first one is about the evolution of community flood standards. And this has to do with just what people were thinking over the decades in the last century and a half, really. And when we talk about Harris County, you really have to understand the terrain and the situation. You know, the county was naturally flood prone. We had a lot of natural channels. There were 800 miles of natural channels that nature gave us. But we also had a natural floodplain across there, and we didn't have any of those lateral drainage channels, so you could really say that the whole county was flood prone. The bayous and creeks of the area probably looked something like that. Most of the rest of the systems were really small swales across the prairie that you could step across, and that's just some of the natural flooding that we had to deal with. So we had the situation with the natural streams, but those natural flood-prone areas also weren't conducive to agriculture or urbanization, so they set out to drain the land. We now have 2,500 miles of channels. 2/3 of our entire primary drainage system is totally man-made, where no drainage system existed before. And part of this story about the evolution of the flood standards has to do with what were they thinking when they built those systems. What was the intent when they built them, and what is the time period that they built them in? Just for a scale issue, again, when we're talking about the magnitude of what we're dealing with, at 2,500 miles in length, It's the distance from Los Angeles to New York. So when we're talking about this large system, it is an extensive system. And when we talk about the population growth, I'm going to come back to this one in a minute, but just to show how the population on the timeline there, those are census years on the bottom, and the population growth. And I'll show you how our understanding of flooding changed during that in the later slide. You also need to understand a little bit about our drainage systems. Each one of those colors on that map is a unique watershed. It has its own independent flooding problems, and water has to fall on that area for that area to flood. If it falls on the White Oak watershed, it doesn't affect Cypress Creek and so on. So we don't have a plan for flood damage reduction. We have plans. Each one of those needs a separate plan. You need to also understand which direction the water flows. When the rain falls out on the north part of the county, those blue lines up top show that it drains to the east. Everything on Cypress Creek, Spring Creek, Willow Creek drains to the east over to the San Jacinto River and out to Galveston Bay down the river. All the green lines in the center of the map there are what drain to Buffalo Bayou and the Ship Channel, and then the yellow lines drain straight to Galveston Bay. Now, a little bit about the history. The farthest I could find on documentation of flooding issues was in the early 1900s. This was 1908. There were about a dozen drainage districts around the county, and those followed roads. They didn't follow watershed boundaries, and they had a drainage engineer that was looking at their drainage. I found the first drainage report, 1908, for Drainage District Number 1, and that's the area on Upper Brays Bayou, and George Horton was the engineer. That first quote in there says he's seen several hundred acres underwater for days after a large rain. That was their criteria, a large rain. And he's going to lay out the system to flow downhill, which is still a good idea. And he had all these channels laid out as part of this system. And he has this schedule of laterals and ditches. The ditches were the big ones. Those were the ones that were going to be 4 feet deep and 4 feet wide, with a 1-to-1 side slope on them. And that's the table. The column in the middle there is the depth of the system, 4 feet deep. And again, what they were attempting to do with this, now we get into the other systems he was building, there was 44 miles of channels that were going to be dug as part of this, and the standard size was 4 feet deep and 4 feet wide. So you can tell they didn't have rainfall records. They didn't have a criteria for what they set out to do was drain the land. And even today, what we have is a county that drains very well, but still floods occasionally. And so those floods would continue, and particularly devastating floods in 1929 and 1935 threatened to wipe Houston off the map. At the time, in 1935, the Houston Post was quoted as, "Let's not forget again as we did in 1929." And this was a time when the federal government had just passed the Federal Flood Control Act in 1936 that allowed the federal government to get involved in local drainage issues. They always thought that local flooding was a state and local issue and that didn't have a federal participation opportunity. And so the Corps of Engineers was invited in after the 35 flood. By 1940, they had the definite project plan. I always like how positive they are on this. This is the definite plan. And that plan was, you can see on the west side, Addicks and Barker Reservoir were part of that plan. There was a levee up in the northwest corner there along Cypress Creek to keep the natural overflow from coming down into Addicks and Barker. There was a third reservoir over on White Oak Bayou, and then there were these big bypass channels that were going to go around to the south, out to Galveston Bay, and around to the north over to the San Jacinto River. And the Corps of Engineers had the right idea. What they had was what they called a standard project storm. Now, that's not a storm that has a frequency tied to it, and across the nation, the amount of rain they would design for would be different. But the standard project storm and the standard project flood had to do with the most amount of rain that is likely to occur in an area. And just as an example of that is Brays Bayou. When they designed it in the 40s and 50s, the design rainfall was 21 inches of rain in 24 hours, about double what our 100-year rainfall is today. And they allowed for future development of the watershed. But they didn't understand the true impacts that development can have when you channelize tributaries, when you add the amount of impervious cover that we have. And that channel that they built in the 60s can still carry the same amount of water that they designed for, but it's not a 21-inch rain, it's a 7.5-inch rain, which is about a 10-year flood event. And you'll see in a minute that the Corps had to abandon that. That's, you know, I'm sure when you think of flood protection is I want to be protected from the most rain that's likely to occur. Economically, that's just not the case. What we also had was the creation of the Harris County Flood Control District as a result of the Corps of Engineers' involvement. We're a special purpose district. We're actually created by the state legislature. We have taxing authority, so you need representation, elected representation. And you already had an elected body that covered the same geographic area as us, and that was the county commissioners. And so they made the county commissioners our board of directors as a special purpose district. And our district was created under the same constitutional provisions that your municipal utility districts are created. That's how we came to be. So moving forward from that, a lot of that definite project plan didn't get built. A lot of it had to do with World War II, that the project stopped for a while, development overran the area, and they weren't able to acquire the right-of-way economically to do that. So we go on to 1944, and there was a petition from the public to the county commissioners asking them to sell $9 million worth of bonds for flood control purposes. And they say what they want the court to do, and the last bullet there says they want to remove 4 inches of rainfall in 24 hours. That was their objective in 1944. We know today that that's about a 2-year rainfall event. So it's just to show you some of the evolution of what people were thinking, what they thought was appropriate at the time. And they listed all the ills of the world that could be solved if we could handle 4 inches of rain in 24 hours, which we can still do today quite easily. These are some of the ones I'll skip over. So by 1957, headlines, county will have control of floods in another 5 years. Obviously, they didn't know what a flood was at the time. But this was the mindset is, no, we've got a good drainage system, and that's what's addressing the needs of the community at the time. And then we get into the 1960s. There was this comprehensive study of drainage for metropolitan Houston. It was a joint effort between the county, the city, and the flood control district to study the entire plumbing system. It got into the streets and the storm sewers and the ditches and the bayous and creeks. And when they were looking at the criteria for this, this is just a schematic to show how your storm sewers interact with the bayou, but it also shows that the streets can flood well before the bayous even know the water's there when you get an intense local rainfall. We had a lot of that in the April and May floods this year. It's a very intense rainfall. And they talk about criteria. They say storm sewers typically are designed for a 2-year storm event. That's your street drainage. But they also say that the ditches and bayous ought to have a more extreme design criteria because of the importance in reducing flood damages. So by the 1960s, they looked at a sliding scale, and that sliding scale gave us, based on drainage area, anywhere from a 2-year level of protection up to 25-year. That was the maximum they talked about. And that drainage area there is about 24 or 5 square miles. Brays Bayou, for example, is more than 100 square miles. So by the time you got 1/4 of the drainage area contributing, the rest of the system, they would, under this criteria, would only be designed for a 25-year event. So we get into the 70s, and this is really the era of limits. This is when we started realizing the limits on finances and on environmental. You see all the environmental laws on the bottom half of that came into play then that really caused a lot of issues with trying to do it the old-fashioned way and put a lot of delay into projects. About the same time, the Corps of Engineers, those are those 3 things I showed before, their standard projects and their probable maximum floods. Those are good ideas. But then they came up with this design flood. And this is where they want to maximize the benefits over the cost. What they're saying is that economics is going to control, not the engineering on this. And the design flood nationwide on flood damage reduction project, the Corps of Engineers struggles to justify anything more than a 25-year level of protection on their projects. And the projects that we're building right now in Harris County with the Corps of Engineers are on the order of that level of protection for some of the watershed, because that's all they could justify economically. And Now, there's another quote that just says, we went from engineering to economics to environment to control how we get things done. And now we're moving into the late 60s. The National Flood Insurance comes into play. 1968 is when it was federal law that enabled the flood insurance program. Didn't come to this area until the early 70s. But in the early 70s, they had what they called flood-prone area maps. And these were very gross approximations of, I mean, the lines were just penciled in to show where floodplains might be. And they were drawn on topographic maps with 5-foot contour intervals, 5 feet in Harris County. Those were very far apart. Those same maps were converted over to what they called the flood hazard boundary maps in the early 70s. And these were actually, the flood insurance program was administered under the Housing and Urban Development. And in the 80s, we looked at our design criteria for our channel systems and also developed hydrologic methods to be able to determine what a 1% floodplain was. And those were the first detailed studies. This is the first time we actually defined the 100-year floodplain with computer simulations, with the technology to really understand what a 1% flood meant. And this was the first time we actually produced maps that had elevations on them so you would know what the 100-year floodplain was. This is the mid-80s now, 85 this came out. But then we move farther into 2000. We have what's called LIDAR. It's a laser surveying technique from airborne lasers that measure the ground elevations. And we got the best definition of the ground we've ever had with this technology, and we're able to do much more detailed studies that would further define the floodplains and just more on the technology. So here's a quick review from the early 1900s. 4 feet deep and 4 feet wide was the standard. 1930s, that good idea of a standard project flood that proved to not be economical in the long run. 1940s, the petition from the public, 4 inches of rain in 24 hours is what they asked for. The 1960s, maxed out protection at a 25-year level. 1970s is the introduction of the National Flood Insurance Program, first time anybody talked about the 100-year flood. And again, that was insurance. These are flood insurance rate maps. They're talking about the risk and what should be insured at the time. So in the 1970s, we got into the flood insurance program locally. 1980s were the first time we had detailed flood insurance rate maps. And then in 2000, we really advanced the technology to further understand our risk. Now this slide shows how that plays into the population, those same milestones I just read off there. And you see on the right-hand side of the graph, in the mid-80s, there were already 2.5 million people here. Those channel systems that were man-made were being built and being surrounded by land development as they went. And then we come in after the fact and define the floodplain. So that's a quick history on that. I want to get into looking at the flood itself. And back to those watersheds that we're talking about, all of these have separate targets. And when we talk about these 100-year floods happening 3 times in the last 2 years, you know, the definition of the rainfall and the flooding is important as well when we're talking about a 1% chance of that rainfall being equal or exceeded in any given year at a location. So the big floods in 2015 were on the southwest part of the county in May. They were on the northeast corner of the county in October. They were up in the northwest corner this April. And so it's not raining the same in all the places is my point, is we do have a risk of flooding. I'm going to get a little technical here. I'm going to avoid getting too deep into this. But we also have 3 zones, and there's 3 zones across the county because the rainfall that we're using for the 100-year flood, it increases toward the coast a little bit. And so there's these 3 zones, and in here you can see, you probably can't read that, is that Zone 1 is the northwest part of the county. That circled number is the 100-year, 24-hour rainfall is 12.4 inches. In Zone 2, it's 13.2 and 13.5. But this table, we're just going to focus on Area 1, or Region 1 on the northwest side of the county. But to understand that this table makes up a lot of combinations of, it's all about how much rain falls over what period of time. And so in this table, down the left-hand side, those colors represent a 2-year to a 500-year, and then across the page is the duration of the rain, and the numbers increase with the duration that creates this frequency situation. Let me just show what I'm talking about here is that for a 24-hour storm, that you can have a 2-year, you can have a 5-year, you can have a 10-year. Those volumes all increase across there, and if we plot all those things across here, that top curved line is the 24-hour time period. You got rainfall on the left, and then you got frequency across the bottom. Now, that's in a 24-hour period, you can have lots of different frequencies. But then if you look at, for the 100-year alone, and all the different durations that could be a 100-year storm, those plot in this direction. So a 1-hour storm, 2-hour storm, 3-hour, so on. That's what you end up with, is that line there represent what the 1% chance of that rain being equal or exceeded. I told you I was getting a little technical, that's about it for that. But what I'm going to show you here is anything that plots to the right of that line is well in excess of the 100-year rainfall. And anything to the left would be less. Now, I talked about the floodplain maps a little bit, and people are more than often surprised to know that those floodplain maps do not represent any actual storm that has ever occurred in Harris County. It's theoretical based on rainfall. Rainfall is only the consistent factor that we have over time. Channels change. They change size, you change development, you have projects, you have detention storage, so the stream flow records aren't uniform. You don't have a period of record where everything in the watershed stayed the same, so rainfall is what we use. Now, what we have is a rainfall distribution. Now, this is what's used, and that's the amount of rainfall per hour for a 24-hour period, but in there is that 1 hour, 100-year, 3-hour, 100-year, 6-hour, 100-year are all contained in that peak through there. And what you'll see is that we also account for losses. The water goes into the ground when it's raining. Those first 14 hours, it's very slight rainfall, it's soaking the ground, and then we get runoff. And we have models that change this rainfall into runoff, and then we've got computer simulations that take the runoff and turn it into depth. So these are theoretical. Now, all these models that we're using, of course, we calibrate to actual storms, but then it's this one uniform rainfall that's used to define every single floodplain in Harris County. And the floodplain maps that everybody's familiar with show a 1% flood, and they show the 0.2% flood, or the 500-year. But trying to understand what that means, I mean, quite often people look at this and think that, well, there's some magic wall there, and the rain keeps raining, it's not going to go any farther, it just stays there, and of course it doesn't. And we have this schematic to try to understand. The home on the left, home A, is in the 10-year floodplain, and we talk about that having a 10% chance of flooding in any given year, but then you look at over the life of a 30-year mortgage, it has a 96% chance that it would flood. And then we have the home B is built right at the 100-year flood level, and it has a 1% chance of flooding in any given year, but then it's also got a 26% chance of flooding over the life of a mortgage. So the fact that you're near the edge of the floodplain, and what happened on this storm is some of the flood levels exceeded the 100-year floodplain, and so there was flooding outside of the 100-year floodplain, which I'll show you, and that's that home C over there, which is in the 500-year floodplain. Of course, 0.2% chance of flooding, but it's there, and 6% over the life of the mortgage. That's your engineering lesson for the day. We're going to go right into looking at the rainfall. And the rainfall is really important. You know, people don't want to talk about the rain because there's nothing you can do about it. Those same storms that came through here, they had hail, they had wind, there was a tornado here and there. You can have an ice storm, your house can catch fire. There's risks in owning property and owning a house in the county. And some of those risks can be mitigated, and some of them need insurance. Now, what we're looking at here is residual moisture conditions, antecedent moisture conditions for March of 2016. were 200 to 400% above normal. The ground was already soaked from the rain that had been occurring. Then we had the storms that came in. Of course, there was a first round from 7 p.m. to 1 a.m. and a second round from 1 a.m. to 8 a.m. And these are just some of the numbers to give you an idea of how severe some of the rainfall we picked up. 5 minutes, we had 1 inch of rain, times 20. How many inches per hour is that to get 60 minutes? 15 minutes of rain, 2.2 inches, and so on. You can see how severe this was. This shows the same information on the top side, but the bottom were gauges outside the county that were even worse. This was over in Waller County. That wasn't part of our system, but we got this information over there. You can see the types of numbers they had in Waller County. And then just looking at a comparison to some of the other events. And again, we're looking at 1 hour, 3 hour, 6 hour. It's different durations of rainfall in the same event that had different frequencies. And this recent one is at the bottom. You can see it, of course, exceeded the Memorial Day flooding that happened on the southwest side of the county primarily. The 2009 flooding had greatly exceeded that in terms of the rainfall amounts. Didn't exceed Allison, though. Allison is still off the charts. And just thinking about some of the more severe storms in this area in the last 37 years, Tropical Storm Claudette dumped 43 inches of rain in 24 hours, which is still a U.S. record. Tropical Storm Allison, we had 28.5 inches of rain in 12 hours. So it can get worse than we had. And then the Tax Day flood, this was one of the out-of-system gauges in Waller County, 23.5 inches in 12 hours. And we plot those rainfall isohydral maps just to show kind of the distribution. The pink lines are the streams that experienced flood conditions and the overall rainfall. And now this didn't mean a whole lot. We're calling it a 12-hour storm. There were some areas that all the rain happened in 6 hours, but to get it all in that same band of frequency from one of those tables, we called it a 12-hour storm. And this shows you the frequency of the rainfall rather than just the volumes. This has to do with how many inches fell in that 12-hour period. And so the green area is a 10 to 50 year event. The yellow is a 50 to 100 year. The orange is 100 to 500 year rainfall event. And then we go 500 to 1,000 and greater than 1,000 with the darkest pink out there in terms of how rare the rainfall was. We did something similar with the frequency that the flood levels achieved on the major channels. You know, there's a lot of tributaries we're not showing that the ones behind your house that caused your problem aren't shown on here. And I want to look at that in a little more detail just to understand this. And so those dots up at the top, we're going to look at Spring Creek first. Those are where our gauge locations are. And I'm going to use that graph again to show you how those areas plotted. Remember, anything to the right of that red line is in excess of the 100 year. The next solid line over is the 500 year rainfall. So that we had some of the rainfall in Spring Creek that was out around the 200 or 300 year rainfall. Cypress Creek, main channel downstream of 290, just to look at those areas. This is, well, we've got one way out there on the county line. It's hard to see. There's another red dot way out on the left of that slide. And this is how those plotted. You know, it went past the 500 year, past the 1,000, or to the 1,000 year on those lines. That's how extreme the rainfall is based on rainfall records, which some of the rainfall records are more than 100 years of record. Now, Little Cypress, I want to talk about that in a little more detail, just as an example. I think there's several folks here from the Little Cypress Creek area. We'll just look at that a little bit closer, where those gauges are out at Becker Road, Cypress Rose Hill, and Kluge Road. Now, something to notice, the brown line that goes around that, that's the watershed for Little Cypress Creek. And the numbers there show that the total drainage area is 52 square miles, and then we average more than a foot of rain over 52 square miles that all had to come down Little Cypress Creek. And then up at Cypress Rose Hill, it's about 40 square miles. But also notice, up even past Cypress Rose Hill, the watershed is very narrow. From the north to south, it drains to Little Cypress Creek in the middle there. but it doesn't take long for the water to get there because it's so narrow in that point. And this is to look at the rainfall that occurred. This is out at Becker Road. We had 2 rainfall events, basically. We had a first rain. There was a gap in time, and we had a second rain. I'll show you what that means. When we look at Cypress Rose Hill, you can see same thing. We had a rain that filled up the creek, and then we had a rain on top of the full creek. It was a really unusual setup on that. And the rainfall, this is down at Kluge Road, same type of thing with that gap in there. I'm going to show you that in a little more detail. But again, we plot those, and they plot well beyond the 100-year flood event. But that combination of rainfall was really unusual. Now, here we get a little more technical again. I'm showing the rainfall from the top here, just so you can see that the first rainfall event, that line that comes up and goes across the page is the stage. It's the stream height. It's how deep the water was getting in the stream. And so you'll see that it came up from that first rain, was starting to peak and come back down, and the second rain hit, and then all the rain from upstream started coming downstream and just kept rising another 5 feet after that first amount of rain. So that second slug of rain on Little Cypress Creek was really devastating. I'm going to talk a little bit about Addicks and Barker. These are the gauges in the Addicks watershed that go into Addicks Reservoir. And these were also some of these that plotted way off the charts, well beyond the 500-year rainfall, and all that water had to go down into the Addicks Reservoir, which reached their peak levels. One last one, just for an example, is White Oak Bayou. You can see upstream areas, upstream in Jersey Village, there's 2 dots there, and then there's 2 dots farther downstream in the less severe rain. And you can see that the 2 upstream gauges plotted to the right of that line, the 2 downstream plotted well below that line. And we had some severe flooding on White Oak Bayou also with this extreme rain. One of the things, that natural overflow, I mentioned in that Corps of Engineers definite project plan where they had a levee to stop the overflow. It's a naturally occurring overflow, and I think there's 3 little lines that show a loop like it's jumping across the watershed divide. This was the most severe overflow event that anybody knows of for the area in recent history anyway. And these are just some of the photographs of what an overflow looks like from the helicopter. The arrows show the direction that the flow is going, and it's leaving Cypress Creek and heading down to Addicks Reservoir. The Corps of Engineers knew this when they didn't build the levee. They bought more land for Addicks to account for the overflow. They didn't buy all the land that'll flood when it fills to the top, though. And this, another one of those graphs that shows the stream rising. This is Bear Creek at Clay Road. And you can see the local rainfall caused that first part of the peak flow. And by the time all that overflow worked its way down to the gauge, it started back up again on the downstream end. But this wasn't that rain thing we saw in Little Cypress Creek where there were 2 rains. It was just the local rain drained off, and then the overflow eventually made it down there. That overflow that was running off of the Katy Prairie and flooding people downstream. The reservoirs, I mentioned, those filled to record levels well above previous records that went up to 102, where it used to be 97. They've got the proposed new outlet works. That red arrow shows that they're building the new box culverts off to the side from the old ones, and just shows some of the devastation in the park. It's the Farm and Ranch Club in the Bear Creek Community Center that was hurt so badly in Commissioner Raddick's precinct. And Barker Reservoir, same thing. Barker Reservoir is in the top of that picture. You can't see the reservoirs because there's so many trees, and the water is, on average, the whole reservoir is 8 feet deep. So out at the fringe there, it's really just around the base of the trees near the edge of the reservoir. And Barker also is getting a new outlet works with a red arrow is. I don't know that y'all are real interested in the reservoirs. I'll make up some time here on that in terms of the slides. Caused real problems with the transportation when the roads went under. The other thing, just some of the flood facts. In addition to all the homes that flooded, there were about 40,000 cars. There were 9 fatalities related to the flooding, but nobody drowned in their home or workplace. It was out when they were moving around during the floods. Federal disaster declaration. occurred. I think ultimately there were 44 counties in the state that were declared disaster areas, not just Harris County. And there's some other statistics there. That's just a condition of our channels and things that we were doing in terms of maintenance. Now, when we get to structure flooding, this is a really frustrating exercise to try to count how many homes flood. Some people don't want you to know their homes flooded. Some areas flooded away from the channels, and the inspectors never made it onto those streets that's ponding and sheet flow in the neighborhood that couldn't get out, that caused house flooding. And this is by watershed. And, you know, if you're interested in Cypress Creek, there's 1,680 homes was the final count on that. Could be more. This includes flood insurance claims, but they cross-checked the flood insurance claims with the building inspectors, make sure they weren't double counted. And White Oak Bayou, 2,080 homes. And in addition to that, 2,700 apartments. Now, you got to think too about, I'll talk some more statistics on this, is that 10,000 homes or so that flooded, and just based on population, 2.89 people per household or whatever, the total population affected by this storm directly with house flooding is less than 1% of the population of Harris County. So it's a devastating flood for everybody that it occurred to, but there's a lot of folks that didn't flood that may not be as interested in trying to solve the problem as you are. Then we look by incorporated areas, just to give you the count. The unincorporated Harris County was hardest hit, obviously. And I mentioned this earlier. This has a bunch of little arrows showing the directional flow. I showed you that Cypress Creek all drains to the east, so all that rain out west that didn't overflow the divide had to come all the way down the creek. And we even had flooding all the way to the east end where the rain wasn't as severe, but all that water had to head that direction. When we look at the primary house flooding locations, these red dots are everywhere. And we had estimated about 60% of the homes that flooded weren't in the 100-year floodplain. Now, a couple of reasons for that. You saw the intensity of the rainfall, and that's flooding the streets. And the streets are trying to flow over land to get down to the bayou systems, especially in the older neighborhoods that they didn't look at where would the water go when storm sewers couldn't handle it anymore. That didn't start being looked at until the 80s. So you had areas that aren't in riverine floodplains that flooded. Those are outside the floodplain. But then we also had flood levels that exceeded the 100-year floodplain and flooded the fringe of the floodplain. So you had homes on the fringe of the floodplain that flooded. So that's where the 60% comes in on that. Our stream gauge network, I hope you all have found that to monitor what's going on in the watershed. We had a lot of these. We set a trigger, an alarm to tell us when there's more than 1 inch in 15 minutes. That went off 107 times on our gauges. That's 4 inches per hour type of rainfall that was going on at the time. The first major test of our new technology, everything worked well. We had 3 out of 140 gauges that failed during the storm that